Number 9. Represent the relationship shown in the table using words, an equation, and a graph. Then determine whether the relationship is a linear function. Okay, so we notice that going from 0 to 1, 1 to 2, 2 to 3, we are increasing by 1. Our elevation is also increasing by a constant amount of 96 feet. So looking at our descriptions, we're starting at a height or elevation of 1,103. So starting from that, so either B or C, we are going up, we are gaining 96 feet, so that's going to be C. So my equation, so we said gaining 96, so 96x, that's going to be our change. We're going up by that, and we're starting at 1,103, so plus 1103. Now for my graph, we are increasing, so it's not going to be A. D is not going to be our choice because we're increasing by a constant rate, and this does not represent a constant rate. So, in fact, neither does C, so it's going to have to be B. And it is linear. And that's number 9. 10. You can make 3 gallons of liquid fertilizer by mixing 10 teaspoons of powdered fertilizer with water. Represent the relation between the teaspoons of powder used and the gallons of fertilizer made using a table, an equation, and a graph. Is the amount of fertilizer made a function of the amount of powder used? Now the number of teaspoons is going to be X, and the number of gallons is going to be Y. Now, the number of gallons we make depends on the number of teaspoons we put in. So X and the number of teaspoons is the independent variable, and the Y is the dependent variable. Looking at our table, we know 10 teaspoons for 3 gallons is going to be 10 for X and 3 for Y. The only one that shows that is B. So that's going to be our table. Now we got to find an equation. So let's look at how to find the rate of change. Looking at our X values, they are increasing by 10 each time. So we're adding 10, and that's my change of X. Looking at my Y's, I'm increasing by 3 each time. So plus 3 is my change of Y. Now the rate of change is change of Y over change of X. So that's change of Y, which is 3, over change of X, which is 10. So 3 over 10. So my slope or rate of change is 3 over 10. So my equation will be Y equals 3 over 10x. My starting point goes here, but that is 0. So I don't have to put plus 0. So this is my equation. So we type in 3 over 10x. And now for my graph, it's increasing, so it's not going to be B. And I have 0, 0 as a point on both of them, as it should be. My second point would be 10, 3. So looking at, hey, here's 10. Go up to 3, there's no point there. So it can't be A. Let's look at C. There's 10 for X and 3 for Y. So that means it is going to be C. So is the amount of fertilizer made a function of the amount of powder used? That is going to be yes. And that's number 10. Number 11. Graph the function represented by the table below. Is the function linear or nonlinear? So looking at the x's, they're all increasing by 1. Looking at the y's, they're all increasing by 1. So that tells me it's linear. That means it's not going to be A or B. It's either going to be C or D. Now, our first point's at 0, 12. So 0, 0, 12. If you look at D, there is no point with x being 0, so it has to be C. And the function is linear. And that's number 11. 12. The cost C in dollars for pencils is a function of the number n of pencils purchased. Graph the function shown by the table to the right. Tell whether the function is linear or nonlinear. Now the number of pencils is the independent variable and the cost is a dependent variable because the cost depends on how many pencils you're buying. So that means the number of pencils is going to be your x's at the bottom of our graph, and the cost is going to be the y's going up or down. Now, going from 3 to 6, 6 to 12, and so on, we see that's not linear. 3 to 6, you add 3, but 6 to 12, you don't add 3. So that means it's not going to be D. It's also not going to be B because we're not decreasing at all here. So that narrows it down to A or C. Between A and C is what numbers are on the axis because they're flip-flopped. So looking at what should be X, we have 3, 6, 12, 15, 18. So we should be going up to at least 18 for our X's. That means it has to be C because on A it only goes to 10, which would be what you'd use for the cost if that was X, which it isn't, it's Y. So that means it has to be C. And it is not linear. And that's number 12. Number 16. For the diagram below, the table gives the total number of blocks Y in figure number X. What pattern can you use to complete the table? Represent the relationship using words, an equation, and a graph. So let's go through our choices. Starting with A, the total number of blocks Y is 3 raised to the figure number X. So 3 to the X. So if I put in 1 in for X, I have 3 to the 1, which will be 3. That tells me right away it can't be A. Looking at B, the total number of blocks Y is the cube of the figured number X. So X to the third. So we have 1 to the third if I put in 1 in, and I get 1. So that works. So I put 2 in. 2 to the third is 8. I put in 3 in for X. 3 to the third is 27, so that works. So it should be B. So that means here, I'll type in X to the third. So it's a cubic function. That means it's not going to be A or D. Looking at B, we see that these 3 points increase constantly, which is not the case in a cubic function. There is no constant rate of change. So that means it must be C. Number 17. The set of ordered pairs represents a function. Write a rule that represents the function. So let's take a look on how to do that. So what we're going to do first to figure this out is to write the coordinates vertically. So 0, 0, 1, 7, 228, 363, and 112. What we're going to do next is see what we add to go from 0 to 7, 7 to 28, 28 to 63, and 63 to 112. The goal is to continually do this until all the numbers we're adding are constant. So we first see what we add to get 7 from 0. We add 7. To go from 7 to 28, you add 21. To go to 63 from 28, you add 35. And to go to 112 from 63, you add 49. So we see these numbers are not constant. That means it's not going to be linear, but put an X underneath it because this represents it being linear because linear functions have an X with an exponent of 1 or just X. Each time we do this, when we go to the right, we add a 1 to the exponent, so the second time will be an X squared once we're finished. And then we'll keep going until everything we're adding is the same number. So now we're going to see what we add to 7 to get 21. That is 14. See what we add to 21 to get 35. And we add 14. See what we add to 35 to get 49. And it is also 14. So like I said before, write that x squared there. And these are all the same. So that tells me my equation will be an x squared function or quadratic. So we start off with y equals x squared. But we're not finished yet, because if you notice, if I substitute one of my x values in for x, say 1, I'll have 1 squared, which is just 1. It's not 7 like I want it to be. So what you do from there is you see what you multiply to this number to get that 7, which would be 7, because 1 times 7 is 7. So now take that 7 and just put it in front of the x squared. So now my equation for the answer is going to be y equals 7x squared. And I can check these. Put 2 in for x, 2 squared is 4, 4 times 7 is 28. Put in 3 squared, you get 9, 9 times 7 is 63. 4 squared is 16, 16 times 7 is 112. So this checks, so this is my answer.